Hello and welcome to the video number 7 of our NVIDIA Omniverse basic training. And for today, we are going to understand the meaning of software in the loop. Basically is testing any software that we are going to be using in our applications or robots in the physical world, but we can test the software in a virtual environment before deploying. Then we will start with OmniGraph, which basically is a visual programming tool for building and testing robots' behavior. Basically, it's drag and drop nodes to define the logic and data flow for robot simulation. Then we will be connecting this OmniGraph to our ROS software. We will see also a couple of examples on how to use the built-in extension in Omniverse, which is script editor. We will be running two examples, one for a USD API, which is more customizable, and another example for the core USD APIs in IsaacSim, which are out-of-the-box functions in IsaacSim. Then we will run this image segmentation model with ROS2. We were going to be using PeopleSemSegNet, which basically is a model to detect people in an image. And finally, we will be testing the same, but instead of feeding the model with an image, we will be feeding the model with the camera in a robot in the scene in IsaacSim. So this is the final step where we are testing how to make use of software in the loop properly. And that's it. Let's go for it. Okay, so this is the file with all the steps and all the links we will be talking about. Here you will find all the commands in order of execution. So only following this, you should be able to finish the lab for today. A quick introduction about SIL, which stands for Software in the Loop. It refers to how we simulate the software that we will use in our physical application, in this case, a robot, but in a virtual environment. In the case of IsaacSim, we have these three tools. ROS2 will allow us to connect the virtual robot with the software. We already tested ROS2 and we have already installed ROS2 in our Ubuntu WSL for Windows or in our Ubuntu instance in AWS in Amazon. IsaacSim can send all information from the sensors in the virtual environment to ROS2, and then ROS2 can validate and take actions that send back to IsaacSim. We have then OmniGraph. OmniGraph will allow us to create logic and actions with no code in IsaacSim. And then we have a Python interface embedded in IsaacSim where we can execute and test scripts. So having a quick look to the links. So here we have an introduction to OmniGraph. You can have a quick look to this if you are interested. Then we have a small lab here using a JetBot robot testing OmniGraph. Here you have an example of the development tools for Python included the Omniverse script editor embedded in IsaacSim as well. And then you have the documentation for ROS2. ROS has been already deprecated, so we will use only ROS2. And yeah, without further ado, let's go for some practice. In our first lab, our first exercise, we are going to set up an environment with a robot to be able to simulate and test in ROS. Then we will build the action graph using OmniGraph nodes. This will allow us to send the information that we need to our ROS software. And finally, we will be driving the robot via ROS. So we will be sending some commands and we will see how do we move the robot from the software in ROS. So let's go to it. Okay, this is my workstation in AWS. If you are following in Windows using WSL, the steps are the same. The only step you will not be able to follow is the last one. And once we get there, I will explain why. But basically, I like this configuration. I have my IsaacSim here with two terminals on the right. We need to go, let's go and set up our environment. We need to go to IsaacSim assets. If you don't see this tab, you should, but if you don't see it, you can click Windows and Browsers, and here you activate the tab. And with the tab selected, we look for environments and we look for simple room, right click, add at current selection. We need to zoom a little bit, zoom in. If you see some grids or some data here, I removed this because I don't like to see all this information around. It's a bit annoying. And I also removed the grid, so you don't see this. And now let's go and add the Nova robot. This and this are not rendering well. I'm not sure why, and probably I will send a question to NVIDIA, but for now, let's go to add the first one, which is will do exactly what we need to do. Let's test a little bit the physics, so just put it a little up from the floor. Click S, so we remove the selections, and then click play, it falls. So yeah, all works fine. And now we are going to add OmniGraph or install ROS, we will see. Okay, red button in the Nova Carta, and we're going to add the OmniGraph. So create visual description action graph. This tab will be opening here. If you search by ROS, you will see all the node related to ROS, but in our, not here, this is another instance of IsaacSim. Here we have all the nodes that we are going to be using here. So let's go first for the playback tick, which is very intuitive what it does. Then ROS to subscribe twist. This is to get the velocity, linear and angular. and we connect this already. Then we are going to get ROS to context. This is the gateway between IsaacSim and ROS. So this will add the context here. Then we add the scale to. This is to convert the units between the real world and IsaacSim, so the virtual environment. Here we add this. Then two of these. This is to separate the vectors units by the 3 coordinates that they will be coming with it. I'm going to leave one here and then Control D to duplicate it. Another one here. What else we need? One array, names. I'm going to leave it here for now. And then a differential controller. We already used that in one of the previous videos. Here, I'm going to need to connect this to this. And let's select this option. So linear speed 2.0, angular speed 3.0. Wheel and radius 0.14. Okay, and then articulation controller, and we are going to add articulation to the chassis link. We already built the Carta robot articulations in a previous video. So this one is already done. It's going to come here and select the articulation controller node and add target, Nova Carta, chassis link, select. And we're going to add two constant nodes, and we're going to add these names to the constant nodes. Joint wheel left and joint wheel right. Yeah, Control D. Okay. I'm going to save this just in case because I don't want I want to save it directly here. For example. What's the problem here? Okay. In downloads. Okay. So the angular velocity, we're going to break it here, and then the z is going to be for the side angular velocity. And then the result, we break it here, and probably the x will be the desired linear velocity. This array needs to be size 2, and the first one goes to input 0, and the second one goes to input 1, and the array goes to joint names. And the velocity command goes to velocity command. I don't know if I leave something, but maybe I can organize this a little bit better. Yeah, well. I hope you can follow the connections, but basically that's it. I'm going to save again the file just in case IsaacSim breaks, which is very often. And next thing we are going to do is to install ROS2. I already have it installed, but we will see the steps to do it again. So these are the commands. Well, first, if you are using Windows, obviously you launch Ubuntu in WSL. Okay, this is just some notes. But these are the commands to install ROS2 Humble. and then ROS2 repository case. You can just follow all this. I don't know if I put some redundancy commands here, but anyway, once you finish to source your ROS2, you can test it. So you should see something like that. And if you want to test the communication with other instances to see that the ROS2 is actually working, you can run in one terminal this, and in a second terminal the listener. Okay, this is just a quick test to see that ROS2 is working properly and it's been installed. And in one of the previous videos we already did step by step how we installed ROS2 and Humble. So I'm going to Control C and Control C to exit. The next thing we have to do, check the file. Well, you can test this as well to be sure that the Humble has been created. Then we install Colcon. We create and build a ROS2 workspace. So I'm going to land here, ROS2 workspace. And then we build the workspace. Okay, and then I don't have to do this again, but I'm just executing again the commands. Just to see that I'm not seeing any error here. I have already done that, but I will do it again. This is to make sure that our IsaacSim is communicating in the same domain, but well, you have to do this in both. So okay. Now maybe you only need to do that in WSL to make available the communication between Windows and WSL. We did that already in one of the previous videos as well. Okay, you don't have to do this if it's communicating already. This is okay. We do that as well in PowerShell if you are using Windows. So I'm going to put a note here. You don't have to do that. We have already done that. Okay, you don't have to do this again. In theory, if you were following the previous videos, you have already connected ROS to Bridge. So what is saying here is, let me show you. Maybe I can launch a second instance. So I'm using IsaacSim selector. And when I launch it, you have to select here the ROS2 bridge to make it available by default, and then use the libraries in Humble. Okay. So we are already there, so you don't need to launch it again. This is only if I want to leave it. Well, this is for everybody, yeah. Okay. Sorry, I'm one of these person that cannot write and talk at the same time. So try next command in your terminal. So we go back here. So this is because we have not connected ROS2 to IsaacSim. It's not, well, it is connected, but we are not receiving anything because IsaacSim is not running. So now if I click play and execute again this, you see we have a new topic, which is for the velocity of the robot. So if I go 1 second back to the script, say click play. Okay. And now what we are going to do is to make the robot move with this command here. To do so, it's already running, we are connected. Now we send the instruction to move the robot. Please note, we have already sent the instruction, so even if I break this, Control C, it's still running. So we have another command here. This is to stop the robot. If I run the command, the robot stops. Okay, can block this. And now we are going to install this package. This is to control the robot with some commands by keyboard from ROS 2 as well. So first I'm going to stop IsaacSim. I'm going to install this package. And then I'm going to run it. So now if I click play, let's see if I click E, it goes front. If I click Q, I'm increasing the speed by 10%. If I click where is the robot? I lost the robot. I need to I will look into what is each key for what thing. I will look into that now. But yeah, it is working. That's what is important. Okay, I took a break and I added the keyboard layout to our file, so you can find it here. Let's continue. The next thing we're going to do is to test the built-in script editor in Omniverse. To do so, we go back to IsaacSim. I have opened a new stage. Just go to File, New Stage from Template, and select Empty. Then go to Windows, Script Editor. We can dock this extension anywhere. And here we have a small terminal with Python for execute Python code. You can add more terminals. Just keep in mind all these terminals are in a shared environment. That means that any variable or anything that you execute in one of the terminals will be available in the next one. And here you have the run button to execute the code. Here you have the documentation about scripting in IsaacSim. And first we are going to run and use the API. So you only need to copy all this code between these lines. Paste it. So basically here we are importing the library that we need. We are setting up the physics a scene with physics, creating a ground plane, adding a cube, and adding physical properties to the cube. So let's execute this. Run. We don't have light, so I'm going to just the grid studio. Maybe I want to have the grid. So yeah, this is our cube, and if you click play, we have physics. And the cube, this is the ground plane. Okay, now we are going to test a core API. So another empty scene, don't save, go back to the file. Here you have documentation about USD APIs. Now we are going to test IsaacSim Core APIs for robotics. So here we are importing some methods from this library. So these are out-of-the-box functions. And let's do the same. I'm going to remove this. And if I run it, we got the same. This time we add some color to the cube. So if I go back, we are adding the position, scale, and color of the cube. Okay, but these are properties of the dynamic cuboid function. So that's the difference between USD API, which are more customizable, and the IsaacSim core APIs. Here you have a documentation for tutorial with a few core APIs and some hands-on tutorials to follow along. And then we are going to be following this now. So we will be setting up a developer environment within our Ubuntu machine, and here you have how to set up the Docker environment for ROS. So we'll be following these steps now. So just very quick, what we are going to do in the next section. So we are going to follow a walkthrough for SIL, software in the loop image segmentation. And the objective is to run the whole flow using ROS and this model, which is PeopleSemSegNet, which is a model to recognize people from an image. And these are the tools that we will be using to achieve this goal. So the goal is to use Isaac ROS UNet, and as I said, this model for people recognition. We'll be running all that inside a Docker container with access to our GPU, and we will simulate input using ROS to ROSback for the images that we want to, for the one image that we are going to test. So first we need to set up the environment. We will be cloning this repository. We will be setting these variables to use them later on, and we will be installing these dependencies. We need to install NVIDIA Container Toolkit. If you were following previous videos, probably you will already have it, so you don't need to do it again. You can just verify if you have it running this command, and of course we need that for leverage tensor RT. Then we will be creating the workspace. We'll be creating this folder, and we will be updating or creating this variable as well to make it accessible. And then we will be downloading the assets from NGC. To do so, we will be creating a custom script, and then we will be querying the latest compatible version. So we are using this script just to make sure that the assets we are downloaded are compatible with the version that we have for ROS. Then we'll be launching the ROS developer container. We have this script for that, and if it is the first time, it will take like 1 hour to create the container. If you have already created it, it will just launch the container. And then we will be installing the packages and sourcing the packages, the workspace, sorry. And then we go to the model. So we'll be installing the model asset using some scripts that are provided directly from the links that I'm sharing as well. But I copy paste the code directly in our file. Then we will convert the models to tensor RT, and we will store it in this folder. Finally, we'll be launching the segmentation demo. We will start in the segmentation node. So here we are going to be using 3 terminals for that. One to store the node, another one to run the inference communication, etc., and a third terminal to visualize the results. Okay, so running this command here. So this is the summary of what we are going to do. Okay, and without further ado, let's do it. Here you have the documentation about this model, and the first thing we need to do to make all this work is to download the IsaacROS common repository. You can have a look to the repository, and you have instructions there, but for us, I have already downloaded, so okay, I get an error, but if you didn't, you can download it. Then we set up these variables to point this repository and the ROS2 workspace. So I set up both. Just I'm going to make a small check. Okay. Then you can make them permanent, because you might need to use it in the future. You might need to install this. You have to install this to be able to download heavier files. Then run this to install the NVIDIA Container Toolkit. We already did that in a previous video. Update, install the NVIDIA Toolkit. Then you can restart. You have to restart the Docker once you have done this. And then you can test if everything is working as expected. So if the NVIDIA Toolkit recognizes your GPU, you should see something like that. Okay. Next thing, we create the workspace. Okay, we'll be using this variable in the next steps. Then you need to log in into NVCR. We already did that in a previous video, but just to make sure that I've already logged, you can test it. In this file, I'm leaving this API key, but it will not work for you because it's working only for 24 hours. So just in case, this is only an example, okay? You need to create your own. Then we clone this in the src folder. Have already done that. We don't need this for this lab. But here you have information if you want to set up extras to your Docker container. Okay. Install this. Let's create this file. I don't know if I have done that in this environment. 1 second. I think I did it, but just in case. Maybe not. Just to separate. From here to here. Copy this. Paste it. And then Control O, Enter, and Control X. Here. And then we make it executable. And then we run it. Basically, we are running these scripts to programmatically pull only the assets which are compatible with the version of ROS that we are running now. Okay, and then We're going to clone this, but I have already done that, I believe. Yeah. Here, you don't have to do this from first. I mean, I'm going to separate this. Basically, I was facing some compatibility error when I was mounting the Docker, and the error was because of the versions. Yeah. So if you remove the versions and just change to that, it will be picking up the latest versions that we have, that NGC has. And here's when we are going to launch to create the Docker. If it's the first time you run this, you will be creating the Docker. If not, you will be just opening it. So, okay, so you should be landing. Now we are inside the Docker container. For the first time, install this could take maybe 1 hour, so be patient. It's a big file, need to be downloaded. You will need to have at least 30 gigabytes free, I believe. Okay, we are here. Okay, that's true. That's only true for when I'm running it from Windows. So I'm going to remove that. And because now we are in the Docker container for ROS, we can run Isaac ROS packages. So let's going to do that. You can put these commands in ChatGPT if you are curious about what they do. I just compiled all the instructions that we need to follow to be able to run the exercise with people segmentation. Okay, I'm going to cut the video for a second. It finished. Now let's open this folder. But it's the same folder I was. So what's the last command I executed? That one. So now we use Colcon to build this. We source it. And now we prepare the people segment model. Okay, here you have the documentation. All the steps that I'm following are in these links that I'm leaving inside the file. So you can install this from the source, or we are going to do it directly from the Debian package. So I'm going to copy this. Now we're going to prepare the model for the people recognition. You can test it here if you have installed it properly. So you should have this folder created after this. Here I leave you 2 links for the documentation related to that. And then we're going to start the image segmentation. First we need to install the dependencies. It's a bit long, but the good news is that all of that is provided out of the box from NVIDIA. So this model is already working, and this is for one model, but if you need to test another model, you can only run the dependencies and run it. Now we are going to launch it. So they will be including an example. So we will be using a photo which is provided, and we will test the model in that photo, that photograph. Now it was started. Okay, so now it's running, but we need to jump in another terminal. Okay. That should be already done. In a second terminal, I'm going to clear this. Okay, I'm jumping inside the container in a second terminal. Now both are communicating. Now we need to open another terminal. And this is to visualize what is happening for our understanding. Oh no, failure. Let me see what happened. 1 second. Oh yeah, never mind. I need to jump into the Docker. Yeah. Now it should work. Yeah. Success. So here in this menu, I should be able to see this is the image that we are analyzing, okay? And this mask, another one, this one is the objective. So we can identify people from the photo, yeah? Okay, this is giving the model a photo for testing. Now we are going to do the same, but from a camera, from a robot in IsaacSim, and we will send in what this robot is seeing to this model, and this model will be recognizing people that we are simulating in our virtual environment. So that's the problem that I have for the Windows user. You will not be able to follow the next steps because, let me show you. Because the Docker container is not able to communicate to IsaacSim. So you can make a quick test and you can let me know if you find a solution for that. I couldn't find any solution, but what was the code? This one. So here you see these are the two topics, but the only two topics that you will see if you are not connected to anything. But if I open one of our recent exercises, if you click play here and I run those topics, you can see that I'm communicating with IsaacSim. So if you are seeing this, it's okay. You can make the next exercise. If not, you need to be working in a Ubuntu machine. Unfortunately, I was not able to make to connect the Docker container with IsaacSim, or even connecting the Docker container to the Ubuntu user in WSL will be enough, but it didn't work. And finally, we are going for the last section, which is going to be to integrate the Isaac ROS image segmentation with a simulated environment in IsaacSim. So we are going to be opening a sample in IsaacSim, which is already ready with the robot and some people there. And then we will demonstrate how software in the loop enables testing and validation in a controlled virtual settings. So the first thing we're going to do is going to Windows examples, robotics example. So we are opening this tab. Inside this tab, we look for ROS2, Isaac ROS. I'm not sure if it's that one. 1 second. Yeah, sample scene. So let's go to open that one. Load sample scene. The first time you are loading it, it might take a few minutes. So I'm going to stop the video for a second.